My name is Michael Taggart. We're going to be talking about writing offensive tools in Rust, why you would do it, and how it works, and why I think it's kind of cool to do this in Rust. This is going to be a calorie-rich talk, and we're going to be doing some live demos. So you paid for the whole seat, but you'll just need the edge. So as I said, my name is Taggart. In my day job, I'm a senior cybersecurity researcher at a healthcare organization. Yes, we actually do exist. I do my research by way of a lot of threat hunting and adversarial emulation. And I'm a big believer in the maxim that the best defense is a good offense, which is why I write my tools this way. Before I did this stuff, I was a teacher, and I like to think that I still am. So I do a lot of Twitch streaming on this material and other sorts of programming and tech adjacent material. And I'm a programming language dork. I really love just exotic and rare programming languages. I really love Haskell, although I don't get to write in it that often. I like Racket. Prolog I struggle with, but that's kind of how I got into Rust. So how I got into Rust was kind of the opposite of how most people tend to get into Rust. I was not a C or C++ or C# programmer by any stretch of the imagination. I was a web developer. Okay, so most of the code that I was writing day in, day out was in JavaScript and TypeScript. And in fact, I was doing that by way of being a computer science teacher. But I somehow fell into Rust probably because of Mozilla talking about it. And I found it, I was really interested in how to start thinking about systems programming languages. And at the time, I'll be perfectly honest, C and C++ scared the pants off me. But Rust has this adorable little mascot, Ferris. How could you not love him? How could you not feel safe and welcomed by Ferris? That's why he's going to be across every one of our slides. And I will say that when I started to pivot into Infosec, and I went to my very first Infosec Con in 2018, the very first book that I purchased was this amazing volume, Hacking the Art of Exploitation by John Erickson. A lot of you know this book, I'm sure. And since you know this book, you also know that a large chunk of it is just blobs of C. And because I bounced so hard off of C, I was discouraged at first, but I also was thinking, okay, I know that I need to understand why bad programming in C is dangerous, but I also wondered if systems programming in other languages made a lot more sense. And so I kind of got into Rust, I would say, at like the right time, because now it has this massive cult following. It's a meme to rewrite it in Rust, although things are getting rewritten in Rust. Most recently, I saw the fish shell, which is my shell of choice, is getting rewritten in Rust. So I missed C and went right to Rust. But I've gone back and learned C, and I will say that actually working in Rust made C make more sense because of the way that Rust walks you through memory management. So if you're struggling with C, maybe take a detour to Rust. Something to think about. The first big project that I wrote offensive-wise in Rust was OffensiveNotion. And we're going to see OffensiveNotion. By the way, I should mention, 100% of the code that we will demonstrate today is going to be available on GitHub with links at the end of the deck. But I'm going to kick off with OffensiveNotion, which is a partnership between myself and my good friend and now business partner, Husky Hacks, also known as Matt Kiley. Husky and I wanted to write a command and control framework. And we wanted to do it in a kind of interesting way. We wanted to leverage the idea of trusted sites, sites that generally speaking can't be blocked in enterprise environments because people use them for their work. So things like OneNote, Google Drive, GitHub, get the idea. The one that made a lot of sense to us to try to exploit was the Notion note-taking app. The reason being that the note-taking API, the Notion API was so clean and allowed us to easily send data in a useful format back and forth. So the way that this agent works is that you set it up with a config, and you can either compile that or use an external config, and it will use the Notion API. It even disguises itself as the Notion app, and then transmits and executes your agent commands using Notion. So you actually use a Notion page as your interaction layer with the C2. You'll see how that works in just a second. Now, originally, because not everybody on the team was familiar with Rust, we were going to write this in Nim, which is another exotic language that I like to collect. But we found some critical bugs in Nim that stopped us from using it, and we went right to Rust, and we never looked back. One of the reasons we never looked back is because Rust forced us to reason carefully about our code in ways that made the code better. It also, because of the way that Rust does error handling, made the agent pretty much bulletproof. Because of the way that you have to handle errors in Rust using certain typing like result and option types that must be dealt with, by result, your, pun unintended, your code becomes more stable. And for a C2 agent, that is critical, right? You can't have that thing die. Okay, let's take a look at OffensiveNotion and see how it works in general. So I'm going to start by bringing up just my user PowerShell here. And the reason I'm doing that is because I'm going to launch it from the command line with an external config, but I also want to show you that when we compile this thing for real, we actually compile it with a modified Notion icon, so it does look a little bit sketch, right? It looks this way, and we did this specifically because of the way that we do persistence with the agent. We put it in places where you might be looking at icons, and so, yes, it's red, but it looks like the Notion icon. Okay, so we're going to launch this thing, and on the left-hand side of my screen, I'm going to bring up this Notion page. The way that OffensiveNotion works is that you give it a parent Notion page, and that's how it attaches a new page for agent interactions. So we'll fire this off, OffensiveNotion.exe, and give it the config. And two things happen. One, you can see I got this little Odyssey that's my host name down here as a new page. But also, this is an option in the config. It will launch Edge in full screen. That's wrong too. Edge in app mode that makes it look like the Notion app. So it looks as though you're actually doing the thing that the user thinks that you're doing. But let's take a look at the Odyssey interaction page. The way that this works, and this is a little bit funny, no, Notion AI, we will not be using you, is we set up a to-do. And then we give it a command like, who am I? And we tell Notion that we're done with the target emoji. Notice that the command came right back. If we do the next one, we can do ls. And in fact, I can chain multiple commands. I can schedule them, sort of, and they will come back in the sequence that I add the targets. In fact, I can even uncheck the commands to have them rerun. The wiki on OffensiveNotion has an entire guide on agent interaction. But we have a lot of the stuff that you would expect in a C2, including shellcode injection, persistence across multiple platforms, and we even have some kind of cool features like uploading to cloud storage. Because Notion doesn't actually host its own files, it hosts them on S3, we decided to create an S3 and AZ upload functions that allow you to upload directly there. There's one other feature that I want to hang on to until the very end. That's kind of some secret sauce that we did. All right, but that is OffensiveNotion. Let's shut down the agent. We also have a self-destruct, but we'll just shut it down for now. And that kills the process remotely. Let's talk about some things that you may have heard about Rust, and we'll dispel some myths and maybe confirm some. You've probably heard that Rust is hard, that it's one of the hardest programming languages to learn. We'll deal with that in a second. You've probably heard that it's a systems programming language. It's low enough that you can write whole operating systems in it. That is true. Check out RedoxOS. You've probably heard Rustaceans like me tell you that it's memory safe, but then you've probably heard some other folks tell you that that's a myth and it isn't really memory safe. You've also probably heard that it is screaming fast, but that it makes gigantic binaries. So from an offensive perspective, you might be concerned about the file size of your payloads. Here's what's true about all of that. The Rust syntax is hard. If you are unfamiliar with typed programming languages in particular, if you've done Python and just JavaScript and no statically typed or strongly typed programming languages, Rust is going to be a big challenge for you. And I never, ever, ever recommend that Rust is somebody's first programming language. Sorry, the teacher in me had to say that. The memory model also does take some practice to get used to. As I was joking at the beginning, we do not work with the borrow checker. We pass through the borrow checker and become changed. But for real, as you work through the errors that the compiler tells you or gives you in Rust, you become a better programmer and much more aware of how your data is moving through your application as you write it. So yes, it is a really, really difficult initial phase, but once you get over that hurdle, the power of Rust reveals itself to you in some really interesting ways. Even though it is a low-level language, depending on your definition, it's a systems language, right? It has modern and higher-level language development tooling surrounding it. In particular, the cargo build tool and crates.io, where we host our packages and we can search for packages. And package management, dependency management is also pretty robust. So if you are a web developer, you're coming from a more high-level language like Python, that part of using Rust becomes very comfortable to you because you have all of that built-in tooling to support you on your way. It's not like you're necessarily fighting with GCC flags or something like that as you're compiling your code. I'll also say that the foreign function interface, FFI story, is very good for Rust. And that is critical for our offensive work, as you'll see, because one of the things that we use that interface to connect with very frequently is the Windows API. It does make big binaries. That is just true because it statically links everything but libc. But there are some optimizations that you can add to your compile in order to make them not as big. So just to give you an idea, the entirety of OffensiveNotion, which is thousands of lines of code, clocks in at something like 17 megs compiled to a release on Windows. So it's big, but it's not bank breaking. All right, here's what's true for offensive operators. And this is really what forms the core of what I want to share today. It is simple, trivial to cross-compile Rust binaries. So I develop almost everything I do on Linux because that's my preferred development environment, but it is trivial to build on Linux for Windows and even for Mac OS. OffensiveNotion as an agent is built for Windows, Linux, and Mac OS. All three target binaries are available on the GitHub repo, but the build process also takes place all from Linux. Similarly and related is that in addition to cross-compilation, there's this feature inside of Rust called conditional compilation. This is huge if you're a developer for cross-platform code. So basically what this means, and we'll see this in a moment, is that you can write one code base, but then optionally include different functions or even different blocks of code depending on your compile target. So I can even go so far as to have a separate main function for Windows, Linux, and Mac, and not have to write separate code bases, just have a single file, and then what gets included is only what's necessary for my compile target. OPSEC thinking, very, very important, because what this does is it reduces our signature space. The fewer functions we don't need to include, the fewer things Yara rules have to hook onto. It really does have excellent Windows API integration. Microsoft actually has a first-party Windows crate that exposes most, but not all, of the Windows API and allows us to work in Rust types with the Windows API. And honestly, it is so great to learn the Windows API using using Rust typing. Most disassemblers right now really struggle with Rust because of the way it, one, loads functions, and two, the way that it structures its types, which is totally different than how C-based programming languages do it. And so for that reason, you get some, I wouldn't say built-in obfuscation, but you're starting ahead because of that challenge that disassemblers have. It is, in fact, screaming fast. And especially once you get comfortable with the concurrency model in Rust, the multi-threaded model, it is bananas. In fact, it's so fast that tools like FerroxBuster and RustScan, which you may have heard about, have to be careful about not flooding NICs when they're doing network scanning. So for example, with FerroxBuster, I never ever run that thing at full speed because it will just take down either my own NIC, it'll flood my NIC, or it will take down whatever I'm scanning as a target because it's faster than those servers can handle. Let's take a look quickly at cross-compilation. So this is an example of compiling. So here's main.rs, and I'm going to use cargo build for release. This is from Linux. It builds it built quickly because the dependencies were pre-compiled. And then we're going to look at the target, which is comp demo. But from the same Linux environment, now I'm going to build for release to a different target, in this case, Windows. It built again very quickly, and there's my .exe. The only dependency that I really needed for that was the min.gw x64 library. Once that's installed and the Rust compiler has that target added, you're good to go. That's really all it takes. As I said, we were going to talk about conditional compilation. Here's what conditional compilation looks like. You add a config macro to the top of whatever function or code block or dependency inclusion that you want, and you tell it either Windows, not Windows. There's also a Mac OS, and there's also a Unix if you want to target both Linux and BSD, and Mac OS at the same time, and only the functions that are necessary for your compile target are included. So as I said, the reason that's really important is reducing your signature footprint. By not including functions you don't need, there's less that rules can hook onto, less that static detections can hook onto. There are a couple of other tricks we're going to talk about for that as well. Here's an example of some conditional compilation, different parts of how we do this in the same file inside of OffensiveNotion. So our persist command is a very large Rust file, but we have different options for whether we're targeting Mac OS, Linux, or Windows. So this is an example from Windows where we're targeting registry persistence. You can see that we're loading current version run, and then we'll create a subkey, and then we'll add notion.exe, right, to wherever we decide to put it, in this case, local app data. And we're doing all of this without calling shell commands. We're all using either Rust built in from the standard library, or when we need to, we hook into the Windows API. Here's another example from the Mac OS version of persistence where we use a login item. If you're not familiar, login items are like startup items on Windows. And insanely, you do in fact have to use AppleScript to make this happen. But that's what's happening down at the bottom of this here. But again, this is in the same file as the previous example. And then last but not least, here's the Linux version of it where we have a cron persistence job, where we're creating a cron job that drops right in, and we create a hidden directory with Notion in it. As I said, we're going to talk a little bit about obfuscation and OppSec. There is a tool that I use throughout my Rust binaries called LitCrypt. What LitCrypt does is it takes static strings in your binary and encrypts them with an environment variable key that you provide at compile time. So any static strings that you include in your code, you can use the LC macro, and that will encrypt them. Again, we're talking about reducing signature space here. So what we're seeing here is that this you can't see me string is in the code. However, once we get this ready to go with the use LitCrypt macro and then the LC macro wrapping our string, when we go to compile this thing, it will compile. And you don't have to build it for release for this to work, but I did. When we run the strings command against this, we will see other strings, but we won't see that string. Right? You can pause that video to check my work here, but that particular string isn't present. So again, if you have a lot of static string messages that you have in your code, wrap them in LC, and all of a sudden, those are no longer useful as signature space. And all you have to do to change those is change the encryption key. All right, one of my favorite tools that I've written with Rust is RustyNeedle. RustyNeedle is a dropper to demonstrate reflective injection of shellcode. Here's how RustyNeedle works. It relies on HTTP, and it also relies on base64. I know this seems goofy, but stay with me for a second. It basically goes like this. What I learned is that if you take shellcode and base64 encode it one time, Windows Defender will catch you and decode it, and you're burned. If you encode it twice, it will catch you and you're burned. If you do it 3 or more times, Defender gives up. And so RustyNeedle comes with a little Python script that will just base64 encode your shellcode an arbitrary number of times. RustyNeedle is designed to pull that from a URL that you define, pull it, and then reflectively inject it. It's not meant to be hyper stealthy, but it is meant to demonstrate this process. So here you're seeing some of the code. This is the integration with the Windows API that I was talking about. This is what we import to make this work. And here this is the stuff that you would expect, right? For reflective injection, virtual alloc, right? And we have virtual protect to change it from read write to execute read. And then we do our create thread right here. And you can see we're using null pointers. This is kind of how we interact with stuff that C functions would expect. And then we wait for a single object and we're off to the races. Let's see it in practice. So first, here is my rn.exe compiled payload. And this is going to be looking for, it's going to make a request for note.txt. Over here is my attack box. I have my sliver C2 framework up and ready to go. It's waiting to pick up an MTLS session from my payload. I've got my HTTP server over here waiting to pick up note.txt. And then this is right here how I would do the encoding of any shellcode. In this case, this was one of the session shellcode binaries from Sliver. So I've encoded it, I've loaded it, I'm ready to go. And now if I fire off rn.exe, everything happens. And hey, look, I've got a session. That's it. I make no guarantees about not getting detected by Defender after you start doing extra fun stuff, but this absolutely works a treat. All right, let's kill that session. And we'll close that. And move right along. As I said, every single thing that you see here today is available on GitHub. This is a super fun one. I love this trick. So if you're not familiar with XLLs, they are DLLs that are specifically designed to work with Microsoft Excel. I don't know why somebody thought this was a good idea, but it is. What you are seeing on the right-hand side of this slide is the entirety of the Rust code that it takes to build an XLL. The thing that makes an XLL is a special function name called XL auto open. That is what Excel is looking for when it loads its DLL. So a couple of things to point out here. The no mangle macro that you see on line 3, that tells the compiler to not mess with the function name because that's what Excel is going to be looking for. And it is just bananas that this works, but it works. Now, this is obviously a trivial example, but you can imagine getting really, really interesting with this. So let's see this work in action. So here is my xllrs.xll payload. And if people aren't familiar with XLLs, look how Excel-y it looks. It looks like you should be able to open it, right? It's not even as sus as an executable. So if I double click on this thing, Excel opens. And it does give me this security warning, but we know that people bypass that for macros all the time. And as soon as I enable this add-in for session only, calc is going to pop. It's just that simple. And all you have to do to make a DLL with Rust is tell Rust that you're building a library rather than a binary, and then compile to Windows. And voila, you have yourself a DLL. We know that ransomware operators, as one of their first tactics or techniques, are going to delete volume shadow copies off of Windows in preparation for detonating their cryptor because they don't want any backups available to their targets. Okay. We also know that the naive way of doing this is running VSS admin delete shadows. But what if you had a way of not just not doing that, but also not even invoking WMI to pull this off? You can, in fact, delete volume shadow copies through the Windows API. And that is exactly what corroded shadow does. So in this particular instance, I wanted to demonstrate this because we used not the Windows API first party crate because it doesn't expose this function, which is delete snapshots. But the third party Win API crate, which is direct bindings to the DLL, absolutely does. And so what I'm demonstrating here is interplay between Windows and Rust. And in particular, you can kind of see some interesting things about how we have to handle double pointers and references. For the C programmers around us, Rust references are not quite pointers, but when you do interplay between the Windows API and Rust, you have to deal with both references and pointers. But let's quickly see how this goes. So I'm going to bring up my administrative shell here, and I'm just going to demonstrate that I have a shadow copy right now. There's VSS admin list shadows. And then I'm going to run my corroded shadow compiled binary. And this is exactly what it does. So we do COM programming with Rust. We initialize it, we get the security context, we initialize our backup components, we delete our snapshots, and now I have no more. And I didn't invoke VSS admin, and I didn't even invoke WMI to do it. So I want you to think, defenders, how would you defend against this? How would you watch for this? This is, again, part of the reason I'm doing a lot of this is to prevent people from making lazy signatures, right? No string-based Yara rules. Okay, last piece. I know we're tight on time. This is the last piece. Concurrency is amazing in Rust. And in particular, when we use something called Tokio, which is a third-party concurrency runtime. Rust allows you to do this, but it doesn't provide it itself. But Tokio helps us out. We can do a multi-provider single consumer model where basically we're having multiple threads report back to a single source. We can do this with port scanning, and it takes Rust to Plaid. It's unbelievably quick. Let me show you what I mean. So for variety, I'm going to kick off Rust from WSL in this case. And sorry, I'm going to kick off OffensiveNotion. Here's my new agent. And I'm going to just run my port scan command. 192.168.1.0/24, false 10.0, and then we're off to the races. So this will take, I don't know, 15, 20 seconds, but it's scanning my entire subnet once it has this thing. There it is. So it's going to go run this. You can see that it picked up the port scan arguments. And because it's scanning constantly for new commands, it's kind of why we have the target emoji to tell us that it's done. So this is scanning the entire subnet. And then when it's finished, it will report back everything that it found open. And it's using that concurrency model to do it. I actually spoke to the developer of FerroxBuster to confirm that this was basically the way that he did FerroxBuster, and it's exactly the same. So we're going as fast as we possibly can, although it feels like an eternity during a demo. There we go. And that's it. So we get all of our open ports across our hosts done in a single command right there. If you're interested in getting started, I actually think that the offensive Rust repo, courtesy of ByteBleeder, is a great place to start because it has a lot of samples of how to do this sort of thing. The Rust book, if you want to start learning the Rust language, is the official place to start, and I strongly recommend it, as I do Rust by example. If you're interested in the security side of things, you can check out the Black Hat Rust book by Sylvain Kirkour. It's a fantastic resource to get used to working with things like the Windows API. And then lastly, I actually think because of the amount of work we put into it, that the OffensiveNotion repo has become a pretty solid reference for how to do certain things offensively in Rust. Okay, so if you're interested in checking out the code from today's demos, you can check out these repos. And if you are interested in getting started in cybersecurity and you want a pretty low-cost way of doing it, like free, I also suck at capitalism. And with a friend of mine, Husky Hacks, run the Taggart Institute that has a collection of free or pay-what-you-wish courses, including courses on Vim, on responsible red teaming, ethical offensive operations. We have courses on the history of binary exploitation. So if you want to check that out, definitely worth a visit. All right, thanks very much, everybody.
Thanks for watching. Achieve your next level of skills with training courses at antisyphontraining.com.